Alright, welcome back. This is video 3 on Grey Hat Python. So where we left off is we're looking at PyCommand scripts for the immunity debugger, and in particular there is a find instruction PyCommand script that we're going to look at, and as you can see it's going to look a lot like a lot of the Python code we've already looked at. There's going to be an import or a from statement here at the top, and then here's that main function that we defined. Args are going to be kind of like the arguments or the command line parameters that you pass in. So we're going to instance this object to the debugger. We're going to be able to search the search code that we're looking for. Is going to take the arguments that we sent in, add a space to it, and then make that into save that into a string. The next step here, the search bytes, is we're going to assemble search code, and then we're actually going to search using those search bytes. So then for each hit in the search results, retrieve the memory page where this hit exists and make sure it's executable. So get memory page by address, get access, human equals true, and then if execute, address equals hit. So what the script, now how to actually execute the script. Here we have immunity running, and you can see that I attached to Firefox, or Notepad, I'm sorry, so there we can see I'm already attached to Notepad. To get these to execute now, you go down to the command bar, it's exclamation point, and then the name of the script. So in this case it's exclamation point, find instruction, and no file extension. And now for this one we have to pass our command line arguments. So it's expecting us to send it the instructions that we're looking for within this loaded process that we're at. So let's do jump ESP. Now if we hit enter, we should see that something happened. Here you're going to see right at the bottom, finish searching for instructions, check the log window. So if we go to window, log data, we'll see here a list of found jump ESP and then the address that it references. So just one way to make finding these these commands, what we're looking for, a little bit easier, because we can do it all right within immunity. Alright, the next one we're going to take a look at is called badchar.py. Again, this is another script right out of the source provided by the book, and what this one's going to look for is basically bad character filtering. It's going to try to identify when shellcode that we've sent over to a vulnerable application, if there's been a bad character or something in that shellcode. And essentially what it's doing is it's saying, I'll look at what's in memory versus what your shellcode originally was that was sent over, and I'll compare it character by character and tell you if it doesn't match up. And then what doesn't match up, I'll tell you the offset, and then that way you'll be able to identify the fact that that was a bad character. So why this is important is that there are certain characters that we can't use. An example of that is the string CPY, or string copy. With the null character usually terminating the end of a string, if we sent that null character in our shellcode, then it would stop executing our shellcode, and our shellcode wouldn't work, and would more than likely just cause the host process to crash. So what this badchar will help us do is actually find that and figure that out a lot quicker. So take a look at, actually I'm going to just close immunity for now. We'll take a look at the code. A little high level. Again, similar format. One thing you'll have to look at here is this shell code right here. This is where you're going to copy and paste the shell code that you actually sent over. You can see here is the logic. It's going to be reading. What we're going to do then when we run the script is we're actually going to find a place in where our exploit picks up, and then be able to tell it, feed this script an address in memory, and then it'll read that memory, take that code out, and then compare it to our shell code. So you can see it does that here, and then it just starts going through and comparing it byte by byte. and then here at the end it just spits out the results of what it found. So I'm going to pause the video here and get this set up, and then I'll show you guys an example. Okay, so for the setup on this, what I'm doing, and this will actually look familiar, I've got a Windows XP Home Edition with War FTP running, and I've attached Immunity to it. So we're just got kind of a normal setup going here. And then from my, I believe it was exploit 3, I have a Python script that I modified in order to send and trigger that buffer overflow. So hopefully this isn't too cluttered. You can see it clear enough. All I'm going to do for this example is send it 500 A characters. So I'm just going to double check to make sure running and attached. Okay, and I'm going to go back to backtrack and run the fuzzer. Okay, we can see in the background something happened, and if we go to here, blah, blah, blah. Okay, so here's where my A's started, and give me 1 second. I'm going to pause the video one more time. Okay, so I got a little ahead of myself. What I wanted to do was just send from our backtrack the 500 A's, which is just more or less going to represent my shellcode. And then inside my Windows XP box, I just did a real, I think 40 41s or A's, and then a 42. So what this is trying to represent here is that this is my original shellcode, and then what I actually sent from backtrack was all A characters. So it should pick up the fact that there's a different character. So that's the one thing you do have to paste in. So now when I come back into Immunity, I can feed it in that address location where it starts. So 00A4FB60. Run that py command, and then check the log window. And here we can see, starting right here, that there was a shellcode length of 40. This was my attack shellcode. This is the in-memory shellcode, and that it detected a bad character. So we can see that did actually work, and see the power of that script when trying to when looking at shellcode that we sent versus what actually got sent to the system. So that really wraps up what I wanted to cover in Immunity. I really encourage everyone to look at those scripts in more detail, and in the Immunity library as well for writing your own custom modules. Alright, so the next topic I'm going to talk about is called hooking, and it's going to be two main types of hooking are soft versus hard. With soft hooking, we're going to attach to a target process and then implement interrupt 3s or interrupt 3 breakpoint handler to intercept execution flow. For the hard, those are going to be hard-coded jump in the target's assembly to get the hook code to run. So I'm not going to get into too much Python here with hooking, but I am going to show a real quick demo in the from the Great Hat Python book, just to show the power of hooking and what hooking can be used for, as far as writing malicious or not necessarily malicious code. So going back to my Windows 7 VM, I'm going to open up an instance of Firefox and restore the session. So openrce.org is the website I want to visit, and what I'm going to do, 1 second here. Alright, I'm going to have to pause while I figure out why my VM is not connected to the internet. Okay, so what we're going to do is we're going to attach Immunity to a running instance or a process of Firefox, and we're going to hook into that process, and then we're going to actually intercept these credentials before Firefox sends them, encrypts them, and sends them down the wire. So that's just to give you an idea of the power of what hooking can provide us with. So the book recommends going to openrce.org and then just using this login form, passing it test and test. So we'll attach Firefox. Now the next thing we need to look for is that there's a PR_write method inside one of the libraries that Firefox uses, and that's what's used to write those credentials without going into too much detail, because this is just a demo, and the book kind of does the same thing. We're just going to look for that. So I'm going to use this shortcut and arrange all of the DLLs and such by name, and it's under NSPR4. And now if I go ahead and right click and do a search for name in all modules, or name in current module, I get this listing, and I just need to scroll down until I see these PR write. So double click that. That brings me to when that method gets called or invoked. I can go ahead and do an F2 and set a breakpoint, and then right away I'm going to go into Firefox and hit login. We can see that the debugger hits almost right away. And what I'm going to be looking for is in this window right here. I'm just going to hit F9 until I see the post. You'll see here, I'll just jump to it. It takes a little bit to get there, but okay. So here we can see the ASCII representation. There's a post to that login form. So from here, if we find one of those posts, we right click and then follow and dump, we'll get that over into this left pane, and if we scroll down, here we can see username equals test and password equals test. I know this is probably really hard to see. I don't have a way to zoom in, but it is there. So I was able to hook into that process, intercept that method call, and then actually dump. Now if you follow the book, what it does is it creates a Python script that will look for those keywords and hook in and then be able to pull them right out. And so your mind can really go a lot of different places with that capability that provides. So I'm going to go ahead and kill that, and that pretty much wraps up the hooking. I just wanted to touch on it a little bit so that you're familiar, somewhat kind of familiar with the idea, and you see the power that that has, and the fact that Python really can facilitate the hooking process. The next area we're going to go into is DLL and code injection. So the big thing with DLL and code injection, or what the heart of the DLL and code injection, even though the two ideas are not necessarily the same, they're implemented in different ways, but the heart of it is remote thread creation. So being able to create a remote thread once you've either injected your code or kind of attached to a DLL. There's a couple of key functions. One of them is going to be create remote thread, and then we're going to rely heavily on that kernel32.dll, so that Win32 API. First, we're going to look at DLL injection. And so in order for a Windows process to load DLLs into memory, it must use the load library function. At this point, I'm getting a little close on my time, so I'm going to stop this video and start off with the recording on the next one.